trigonometry is actually the relationship. Now, the relationship between the side length Alright, so trigonometry is the relationship between side length and its angles. Okay, now of course, in the beginning we will be dealing with lots of right angle triangles, but as John Norman asked a really good question right there, it's not necessarily only the right angle triangles, but sometimes we might also deal with non-right angle triangles. Non-right angle triangles. Okay? Right, now let's get started with the right angle triangles here. So when we talk about trigonometry, really we are talking about the relationship between these two, the side length and its angles. Okay? So we're dealing with the angles and side length. So let's say, for example, that's a right angle triangle right there. I should draw it bigger. I draw it way bigger, like that. Okay? So if you draw a right angle triangle like that, yeah? Now, so side length means what? This is the side length. That is your hypotenuse, which is also a side length, and that is your side length. You know what side length means? So side, one side, and then length, side length. Let's say, for example, the classic primitive right angle triangle, Pythagorean triples. That will be 3 centimeters, for example. That the side length of that is 4 centimeters, and the side length for hypotenuse is 5 centimeters, isn't it? Very good, Grace. Okay, so let's say, for example, that's the one. And now, what trigonometry does is we're not talking about, we won't be dealing with just the side lengths, but we are going to involve an angle. Yeah, and that angle is what we call the reference angle. Okay, now that's one of the vocabularies or terminologies of math. Now, so that is our reference angle. Now, ladies and gentlemen, it has a notation of symbol that goes with it. Now, look, I'm a lazy cat. I'm not going to keep writing reference angle every single time. Bro, I'm going to write reference angle equals to 30 degrees, let's say, for example. No, that's too long. That is too long. Yes.
Is that triangle?
Oh yeah, that is one of those. So you can use that, but that means angle, just angle. But it's a good one. It's okay. You can still use that. I'm not saying it's wrong. Equals to 30 degrees. Let's say, for example, like that. They mean the same. So that same place.
I saw a triangle in the books.
Yep. Thank you. I'm glad that you remember. Now, especially for reference angle, we have another notation for that. I believe that you have seen it before.
Whatever it is.
Ladies and gentlemen, it is that. What's that called? Anybody remember? Who remembers that?
Delta, theta, whatever.
What's it called?
Oh.
Theta.
Oscar.
Theta. So theta equals to 30 degrees. Okay, so write that. So theta equals to 30 degrees. So that means when you write theta equals to 30 degrees, it means that your reference angle is 30 degrees. Okay? Now, so what if my angle is there? It is also still called a reference angle. Let's say, for example, that is 20 degrees, for example. Okay? It's not drawn to scale. Now, so let's say that is 20 degrees, for example. Okay? So those are the reference angle. And depending on where the reference angle is, now this is what's coming up next. This is what we're going to talk about now. Okay, so I'm just going to rub this right angle triangle away and draw a fresh one. Okay? Now, we're going to draw a fresh triangle here. Now, if my right angle is right there, and my reference angle is right there, Right, let's not worry about how many degrees that is. Let's put a theta there equals to whatever degrees that is, okay? Now, there is gonna be a specific name given to that side length, and that side length. Now, we have already known, what's that called? Hypotenuse, exactly, stick to that, hypotenuse. Now, and of course, we're not gonna write hypotenuse every single time, it's too long. We just summarize it with H, okay? H, hypotenuse. Now, so what about the other two sides?
Opposite.
Now, here is how you identify the hypotenuse. Remember, the hypotenuse is always directly opposite to the right angle. Now, this is important. Listen carefully. The hypotenuse is always located directly opposite at what? The right angle. Okay?
Good job. That was good. I'm proud of you, Mr.
Mr. D, you get scared from you dropping that.
What?
Did you just get scared? I saw you flinch.
Wow, thanks. Ross, thank you for noticing that. Now, next, moving on. So, if that is the reference angle, now, the side which is directly opposite to the reference angle is opposite side. The common sense. Opposite side or opposite. Now, as you know, I'm always lazy. I just put an O. Okay? O means opposite. Now, doesn't matter. Now, so last but not least, we have already known what's the name for this side, which is hypotenuse. We also know the name for that, which is opposite. Last but not least, we have one more side. And it's called the adjacent. Adjacent. Or we can summarize it as A. Adjacent. Adjacent means the side which is situated directly next to the reference angle. Make sense? Yep, that's correct. Yep, it is an acute angle. Very good. In this case, all right, now, so that's what it is. Okay, so that's trigonometry for start. Okay, so it's just a very basic start for trigonometry there. Now let's take out booklet 2. Ladies and gentlemen, take out booklet 2. Now we're gonna go through some examples. We need, yes. Oh, Norman, I love the questions right there. Now let's do this. Let's do this. Okay, so before you take out booklet 2, John Norman has raised a very good example question here. Now, draw another right angle triangle. Okay, put the right angle there. Cool. Now, but only this time, John Norman suggested that the reference angle should be on the top, right there. So what's that? What's that? Huh? Which one? Which one? The one on the left. So that side, correct. That's going to be adjacent, correct? Because that's sitting right next to the reference angle, isn't it? So that side would now be the adjacent. Now, where is the hypotenuse? Exactly. Directly opposite to the right angle. Now, what about this one here? Oh, it's the opposite, isn't it? Done. That's it. So really, you need to watch out for two things when you're solving trigger. First thing will be a right angle, because that gives you your hypotenuse, isn't it? And the second thing is your reference angle, because that gives you your opposite and adjacent. Got it?
Mister.
And any questions on the other side of the world?
Me! They are always opposite than the reference angle.
Like what? Come again?
The L is always opposite than the reference angle, yes?
The what is always opposite to the reference angle?
The O.
Yes, correct.
Okay, so I got confused.
Yes, you're correct. Yeah. Yeah.
Do you ever have two reference angles?
That's a good question there if you want. Okay? Now, so let's take up booklet 2 right now. I'd like you to turn to, sorry, did somebody put their hand up? Yes, Grace. Oh, not now, later. Okay, so let's hop on to page 396. Okay, we're looking at 7.1. Looking at 7.1 right here, Introduction to Trigo. Now, so should we solve some examples together?
Page 3.
All right, before I proceed, can I please ask Megan, how are you doing there? All good? Megan raised her hand. What's up?
Can you do unit 3 in booklet 1?
Unit 3 in booklet 1. Hang on a second. Who is Ed? What you talking about? Oh, you mean the Trigo one, the ratios?
This is someone's way.
No idea. All right, now, so Megan, are you all good there or what?
Yes.
Megan,
Yeah.
yeah, you can always proceed if you wish. If you already know how to do it, that's fine.
Help in unit 3.
Denise, what about you? All good there?
Yeah.
Yeah? Melissa?
I'm good.
Good. Dylan? Dylan, you there?
Yeah.
All right.
No.
And
Wait.
who's the other? Ross, are you?
Yes.
And Dion.
Yes.
I love how when you say Dion, I just click through his screen.
All right, good on you. All right, now, so let's solve some examples here. Now, if you take a look at page 396, 7.1, now let's do question 1 here. So question 1 says, copy each of the following triangles and use a reference angle to identify the hypotenuse, opposite, and adjacent. I mean, you don't need to copy it. Okay, just answer the question. So let's say, for example, that's triangle FGH, all right, and your reference angle is right there, so you kind of already know what's what, isn't it? All right, John Norman, tell me where's the hypotenuse, where? Very good, FG, isn't it? FG is the hypotenuse. Cool. All right, now what about the opposite?
DH.
GH, very good. All right, now, last but not least, you've got your adjacent, which is right there, FH. Done, that's all you need to do. All right? Okay? Now, I'm gonna jump to question 2 here. All right, if you turn over the page, page 397, I'm gonna solve an example for question 2. All right, Grace, better watch. Now, so question 2A. So I've got a right angle triangle right there. That's a right angle, and that's your theta, which is the reference angle. So they ask you to answer your hypotenuse, your opposite side, and your adjacent side. All right, so the diagram tells you that's 7 centimeters, that's 8 centimeters, and that is 6 centimeters. All right, so what's the hypotenuse? Grace, what's the hypotenuse? What's the length? 10.6 exactly centimeters. Now what's opposite?
7.
7. Very good, because the reference angle is right there, isn't it? Yeah. Well done. Now, and adjacent will be?
8.
That's 8 centimeters. Now.
I have glasses.
All right, now 8 centimeters. Okay, so that's it. It's very straightforward, this topic. Okay, so I believe that you won't have any issues. Now, what I would like you to really do is the problem solving questions.
Oh,
Okay?
Jesus.
Now, I do not believe all of you will have any issues from question 1 to 6. I don't believe that. Okay? I believe you're all good with that, but I'd like you to attempt question 7 and onwards. I mean, well, question 7 and 8. All right? So now, if you can complete all these questions, that'd be fantastic. So just do 7.1. Question 1, I believe, yes, we do have protractors here. Just give me a second, I'll get it for you. Now, question 1 up to 8. Now, make sure you do every single question in there, because they're all really good ones. Okay? All right. So that's for today. That's your theory. Now, the next topic we're gonna talk about is trigonometry ratios, which is the one that Megan was asking me. All right. So that's our next one. Cool. Now I'm gonna that's all for today. I'm gonna stop the recording right here, but I'll leave the class on and open. Okay.
So,